Alright, so before we get started with today's lesson, let's do a quick review. This is called repeated factors. A number's being repeated, and they're factors. So, what I would like us to do is, let's take this repeated factors, and I want to write it as a power. Remember that vocab word? Power is a base with an exponent. So, who can tell me, number one, 7 times 7 times 7, what would that be as a power? 7, that is my base, it's the number that's repeated, and it's to the third power because there was 3 7s. 2 times 2 times 2 times 2. Very good. 2 is my base because it's repeated. My exponent says it was repeated 4 times. 81 times 81. 81 is my base. Exponent 2 means it was used twice. Let's go the other way now. I'm going to give you the power. I want you to tell me what would be the repeated factor. Mainly, how are we showing our work? What does 3 to the third mean? Gio?
3 times 3 times 3 times 3.
What does 2 squared mean? 2 times 2. And what does 1 to the 7th mean?
1 times 1 times 1 times 1 times 1 times 1.
Awesome. Now, you can tell me what is the value of those? What does value mean? What's value mean?
Like how much it equals?
How much does it equal? So 3 to the third has what value? What does it equal? Chance?
27.
Equals 27. Which is awesome because I can either do 3 to the third or I can just think 3 times 3 is 9 times 3 is 27. What is 2 to the second power? What is its value? 4. And the one that tripped up people on homework, which totally threw me through a surprise if they messed this one up. It is 1. I found the people that struggled with this, they were not showing their work. So they saw 1 to the 7th and they said 7. When I asked them to write as repeated fractions and repeated factors and they did this, they go, oh. Because 1 times 1 is 1. Times 1 is 1. And one person goes, was the answer just 1? I was like, yeah. And they're like, well, that's stupid. It's like, thank you. How about this one? You guys remember? I think I told your group this. Any number to the 0 power is 1. It is always 1. There's a long reason how we can show it. It's because we could show, I think we can show it by 4 to the 10th power, and then we could subtract. How was it? I forget. It has to do with going by the 10, and then you can subtract 4 to the 9th and see what, I don't remember. I gotta look it up again, but I've had it working before. It's kind of tricky how you prove it, but it always comes out to 1. How about a perfect square? This will show me if you know what a perfect square is and how we prove it. What do you think? Ainsley, is 9 a perfect square?
Yeah.
Why? I don't believe you.
You can do 3 times 3.
There you go. 3 times 3. I multiply by the same number twice. If you multiply by the same number twice, it makes it a perfect square. So is 12 a perfect square?
No.
I don't believe you. Can you prove it to me?
You can't multiply any numbers by itself to get 12.
I don't believe you. Can you prove that to me? You just made another statement. You cannot multiply any numbers by itself to give you 12. I don't believe you. I think you can. Can you prove me wrong? I don't know. Tough question.
Well, if you try, like, let's say 4 times 4, since 3 times 3 equals 9.
Ooh, I heard 3 times 3 was 9.
Yeah, but if you do 4 times 4, it'll give you 16, and there's no number between 3 and 4.
Very good. That's one way to prove it. 12 comes between 9 and 16. 3 times 3 is 9. 4 times 4 is 16. 12 comes between the two, and I can't go between 3 and 4. The other way, my last group did this, and I like this a lot. They said, well, 1 times 12, 2 times 6, 3 times 4. Those are all the factors of 12. None of them are repeating. That's a great way to explain it. How about 24? Is it a perfect square? Chance?
No.
I don't believe you.
Okay.
You don't just go with okay. Prove it to me. He's like, who?
Because he never says you couldn't multiply. You have to multiply the same number twice or whatever. See, I know I had the right answer, but I don't have the right evidence. You know what? Never mind.
How do you know you have the right answer?
Because it just seems right and let's see. 12 times you can't do 12 times 12 because that gives you 12 something, and you can't do never mind.
I like how you're going with this. I like your thinking. That's what we want to do. Can I have someone help you a little bit, though?
Yeah.
Can you help a minute?
4 times 4 is 16, and then 5 times 5 is 25. No, yeah.
So if I did 4 squared, 16. 5 squared was 25. And 24 came between the two. So 4, 5, those were consecutive. So it's not a perfect square. How about 16?
Okay, I got this one.
Grit?
Yes.
Why? I don't believe you.
Because 4 to the second is 16.
Okay, I believe you. Alright, real quick, let's see if you guys totally understand this. Who can give me a perfect square number?
16.
9.
81. No, it's 49. 144.
Okay, let's go with not perfect squares. Chance.
24.
Are you sure?
No.
Yes, you are.
Yeah.
Great.
57.
12. 6.
3. Let me put that. Alright. Good job. We're going to stop there. Okay, I want to look quickly at today. Oops. Last groups. Ooh, I'm kind of worried because last groups my notes didn't copy over right. Okay. Order of operations. Okay, today we'll work on lesson 1.2, order of operations. Like I told you earlier, our goal here is to write and evaluate numerical expressions using order of operations. I always told you I'm going to explain what that means. So, by the end of today, you should be able to solve that problem. Everyone will be able to solve it and get the same answer. That's the important thing. That is today's goal. Okay? Here's our criteria. How are we going to do it? And to be honest, we probably won't look at this one as much today. But the first way is, first thing you have to be able to do today is tell me, why do we even care? Why do I have to have order of operations? Was it just something that teachers were like, hey, how else can we be mean to our kids? Oh, let's make them memorize a way to solve math. Is that why we did it? And the second way is evaluate numerical expressions with several operations, exponents, and grouping. That's this example. So tell me, why do we do this? And then do it. Okay, what I'd like you to do is you're going to get used to this. Remember when I told you our morning is planner, homework, and get your workbook? Okay, which tray are we? Are we gray tray or black tray?
Black.
We're black for purple day. Okay, I had my last group do this. You are going to get out your workbook every time from now on. Your group, our second hour, are yellow. So, if you would get out, everyone grab a yellow one.
You sure?
Alright, so everyone should be grabbing their yellow. And if I didn't lose mine, that'd be fantastic. Here it is. What I'd like you to do, mine's pink just because that's the sticker I grabbed. But on the spine, you should have a yellow sticker that identifies that's your group. Go ahead and put your initials on there. That way it's quick and easy for you to find yours. So put your initials on there. And then on the front cover, you should have a sticker. You may write your name on there. We are going to go over this in just a second. As soon as you've done that, put your morning work in front of you. I actually forgot to go over your morning work. And I have something to give you. So, first. Oops, wrong thing. Morning work. If I'm in my Avid binder, I should go syllabus. How to navigate big ideas. I have a times table. I'm going to give that to you. I'm going to give it to you right after we finish morning work. You'll put it on there. Because after it is your morning work. Alright, so our warm-up. If you can look at yours and compare it with mine. Remember, we're not really going to explain it, but I'll help you. The very first one said 33.53 minus 0.9 plus 31.5. Remember, you must complete these as part of your assignment. First thing I did was 33.53 minus 0.9. I showed my work and I got 64.17. Oops, I got the full answer there, I'm sorry. I got 32.63. I rewrote my problem and I'm going to add 31.54. And your final answer you got should have been 64.17. When I went to number 2, I added 44.5 plus 27.9, and I got 72.4. Added 13.43. And my final answer would have been 85.83. Yeah, I see a couple people that don't even have their morning work in front of them or looking at them, but that's okay because remember, they are due at the end of the chapter. We're turning them in for a grade for completion. I just showed you how we did them. They're not graded for correctness. They're just to get us in the right idea and frame of mind. Okay, I gave you the times table, so it should go right in front of your homework. When you're done with that, put this Avid binder to the side, and I need you to open up your notebook to 1.2. So it looks like this. Okay, last group I had to tear this out. We're not going to tear them out because I don't need to collect these. This is going to be our exploration. Does anyone remember what do we do during exploration?
We like explore what we're going to do.
Yeah, and you're going to work with your table group. Now, I'm being totally clear with you guys. These first couple lessons, you're not doing a whole lot of exploring because it's kind of review. This is stuff you should know how to do. So we're not really trying to brain solve these. These are pretty much you guys know how to do it in your solving. What I'd like you to do is we're going to look at Exploration 1. And let's just do... I'm going to go over A and B, we'll say. Okay? If your group gets done with A and B, go ahead and work on C and D. But I want you to follow the instructions. It says, work with the partner. Find the value of each expression by using different orders of operations. Are your answers the same? So if you look at A, I have the same equation. 3 plus 2 times 2. 3 plus 2 times 2. On the first one, you need to add first and then multiply. On the second one, multiply and then add. Go ahead, work on this page with the partner, compare answers, and then discuss. Are your answers the same and why not? Alright, if we look at our exploration, you guys got your answers. On A, did you get 10 and 7? If you did, 3 claps. 1, 2, 3. Alright, doesn't look too bad. So when I did this, and I followed what they told me to do, 3 plus 2 times 2, I added first. 3 plus 2 is 5. 5 times 2 is 10. However, I have the exact same problem, but I multiplied first. 2 times 2 is 4, and then 3 plus 4 is 7. Are my answers the same?
No.
No, they're different. We see this in B. Your answer should have been 45 if you subtracted first, and your second answer should have been 9. Why is this a problem? Grant?
Because if we get different answers every time, then there's no way to tell if you're right or wrong.
When we come up with these problems, it's not we're coming up with these problems only to solve in math class. And they're not just, hey, I want to test your math ability. People use these, and they use way more complex ones in real life. Accountants, bankers, farmers. My dad had to do this stuff. I did this when I was coming up with activities, or like I was doing planning a party thing. And we come up with order of operations because a lot of times we have to fill in the blank, and I'm like, okay, I first have to do this, and then once I have the total number of people that are coming, then I can divide it by 5 because that's how many people I have at a table, and it costs me $7 a table, so I'm going to take everything times, and we have these different order of operations. Doctors, technicians, computer analysts, graphic design, people that make video games will use order of operations every single time. If we do not put things in the correct order, we wouldn't get the same answers. And that's really, really a problem. If we were talking about money, and I said this was $45, and you did it, you came out with 9, and it was like, hey, I owe you $45, and you said, oh, you only owe me 9. I'd be like, oh, ching, ching, bling, bling. Here's your $9. I saved myself $36. Big companies would do this. What if that was 45 million and 9 million? Think that'd make a difference? Right now, the Royals are supposed to be selling. David Glass, the owner of the Kansas City Royals, is selling the Kansas City Royals to possibly a guy named Sherman, who was part of the Cleveland Indians. Now, David Glass, he bought the team for $96 million. Okay? And when they decided to sell it, did they just say, I want this much? No, they had to come up with an equation. They had to come up with a way to value the team. I guarantee order of operations came in because it wasn't just one number. They had to look at, hey, we have this revenue coming in plus this. If we divide it by this, we're going to subtract our expenses. And they came up with what the team would be worth. You know what the deal is supposed to be worth?
$10 million.
$1 billion. What they think they're going to sell it for. So he invested $96 million. He's going to sell it for $1 billion. That's a really good investment. So he had to use order of operations. When people, especially people are in businesses, they definitely have it because they never have something that just comes out to, here's your one amount. So order of operations will be incredibly important in your daily life. I'm not even making it up. I've used it a lot. When we get to the real life example, you'll see how. Okay, we're going to be done with this exploration. I know today's is real short. When we do a review, I have a game for us to play. That's really, you're moving around. I think you guys will like it. What I'd ask you to do is close your book. You'll put it away when we have time. And let's get out today's notes. Oh, maybe you want me to hand you the notes. Come on, Elizabeth, quit yelling at me. You should have seen the look Elizabeth gave me. Well, I hope her mom hears this on the recording. She's going to talk to her tonight. Later. Yeah. You're welcome. Alright. So, if you're looking at your notes, we'll start them together. Remember, the way we do our notes, I'm going to model it, and then you guys are going to work together, and then when we come to get the answers, you're going to explain the answer to me. So, we just went over our exploration, and you should be able to tell me why we use order of operations. Mainly, we do it so we get consistent answers. So, if Chance solves a problem, and Kiori solves a problem, and a Jude solves a problem, and I solve a problem, we would all get the same answer. Right now, we're doing our second set of criteria. How do we evaluate it using order of operations? Okay, on your notes, please write your name first. We're going to put our period. We are, did I do 2P or do I do
2P?
Did I do P? Yeah, I think 2P. We are second block, purple day. And today's date is the 28th. Okay, first thing I'm going to do in my notes is I'm going to write two things down. I'm going to write down PEMDAS and GEMAs. Or is it just GEMA? Just GEMA? See, I don't use that one, so I'm not as familiar with it. PEMDAS is the one I've always used. It's the one I like better, just for a couple of different reasons. But if you're used to GEMA, you're more than welcome to use that. I will not be picky on this. This is how we can see math is solved multiple ways. Okay, in PEMDAS and in GEMA, the most important thing to this is one of the things people forget. We read a book left to right. So when we solve our math, we will solve our equation left to right. On here, PEMDAS obviously is parentheses, exponents, multiply or divide, add or subtract. That is huge because a lot of people think multiply first, then divide. But when we go left to right, if a division problem comes first, we would do the division before the multiplication. Also, by the way, if you guys are paying close attention, at the end when we go to start our homework, I'm going to give you a problem that drives me biggest pet peeve, like my wife was laughing at me home because I'm yelling at my computer. On Facebook, there's a post going around with an order of operations problem. Simple. It's like 4 numbers. People are missing it. And they're saying the answer is either 1 or the answer, I think the other answer was like 6 or something. I forget what it is. We'll see it. And they can't argue, and adults are arguing about what the answer is. I looked at the comments of my friends who were making comments that were wrong. One of my friends was a teacher. She even wrote, well, it depends. No, it doesn't. My wife told me I was not allowed to make a comment on it. She was like, you do that? I was like, oh. I had to close it. I was so furious. I almost wanted to call this friend and been like, hey, you stupid. Because you're a teacher. And you go, well, it depends on what you do with the parentheses. No, it doesn't. You follow the rules. That's why we love math. That's why we have order of operations, so we don't have these arguments. And people are like, damn, what's new school math? No! This is nothing new. And you're going to learn this. I did it my last class. They all got the answer right. And they're like, wait, are people dumb? I was like, yes. Okay. Gender. G stands for grouping, which is like our parentheses or our brackets. E is our same thing as pen does. M is
multiplication or division,
which is the same thing. A is
addition or subtraction.
So it's really the exact same thing. It's just, what are you more comfortable with? So here's how we're going to do this. Example 1. Evaluate 12 minus 2 times 4. There's a couple things I'm going to be picky at. I want you to show your work how I am today. For you to get full credit, you have to show every single step. Okay? This part is optional. But I do it whenever I did these problems. If you want to, you may. You do not have to. If you're struggling with it, I would recommend doing this. To the side, I wrote PEMDAS out on every single problem. I did this with my 4th graders, and I actually had them doing pretty much the exact same problems you will as 6th graders. I gave them hard equations, and I taught them how to use PEMDAS, and once they learn that, they're like, well, dude, this is easy. So I'm going to write PEMDAS out, and here's why. I'm first going to look at the P. Parentheses. In 12 minus 2 times 4. All right, left, right. Are there any parentheses or any grouping symbols? Okay, so I'm going to cross that P off. Okay, are there any exponents? I'm going to cross the E off. Multiply or divide. Remember, we are working left to right. So I'm going to go here, and I'm looking for multiplication. Subtraction, multiplication. You should make a funnel. A funnel or like a slide. You go up there, it looks kind of like a drill. We say it's funnel because a funnel is like when I take 2 things and I can pour them in together and they get mixed into one. Well, that's what I'm going to do here. I'm going to take 2 times 4 and I'm going to put it in the funnel, and what is going to come out?
8.
Yeah, 2 times 4, so I'm simplifying. And then you must rewrite your problem. This is the work I want to see. I want to see you rewrite the problem for every single step. 2 times 4 is 8. So instead of having that, I'm just going to simplify. I now have 12 minus 8. Are there any multiplication or divisions left? No. Is there any addition or subtraction left? No. 12 minus 8 filters down to, and it's left. If I followed PEMDAS, I'd be done. Everyone would get 4. Second one. This one looks a little more tricky. So I'm going to write my PEMDAS out. First thing, are there any parentheses?
Yes.
Actually, there's parentheses and brackets. All brackets mean, yeah, it's just like an extra pair. So I'm out here. The only problem I'm looking at is now parentheses 4 plus 2 parentheses times 5. Okay? In my parentheses, are there other parentheses? Good. So I'm going to highlight that for us. And now I'm only focused on what's inside the parentheses. You keep digging in from brackets to parentheses. Keep going. Are there any other parentheses inside these parentheses? No. So I'm going to go to my exponents. Are there any exponents in here?
No.
Any multiplication, division?
Yes.
Inside my parentheses?
No.
No. So I'm still looking only at 4 plus 2. I do not do the 2 times 5 because of these parentheses. I have to do this first.
You have to do 6.
So I will do a funnel. Inside parentheses was 4 plus 2, which is... So I simplified that first. I rewrite my equation. 60 divided by bracket. 4 plus 2 is 6. Do I need to keep those parentheses now that I simplified it all the way?
No.
No, so I get rid of them. And times 5 bracket. I go back because I haven't crossed anything off. Do I have parentheses?
No.
Yes.
Yeah, remember, not just parentheses, but brackets. Do I have a grouping symbol? Yeah, we have brackets. So now I'm focused here. Inside there, do I have any exponents?
No.
Any multiplication or division?
Yes.
5 times 6, or 6 times 5 is... Now, because that's everything that's inside those brackets, do I need them anymore?
No.
So we are done with them. 60 divided by 3. I go back all the way here. Are there any parentheses or brackets? Any exponents?
No.
Any multiplication or division?
Yes.
So I funnel that down, and I get 2. And that is my final answer. Okay, here's what I'd like you guys to do. I'm going to give links bucks for groups that think doing this well. I want you guys to work on 1, 2, and 3. Show all your work just like I did. When you are done, check with the people in your table. If someone at your table is struggling and a little confused, help them. Work together. When your group has 1, 2, and 3 done, raise your hand if you guys are done and have the same answer. Okay? Okay, we're coming back together. A number of groups are getting done. If you're not done, that's okay. Please pay attention, focus. When we get done with this, when you're working on homework, if you're confused, I will definitely help you. So, good. We're actually just a couple minutes behind schedule, so we're doing awesome. You guys should have good work time. You're participating well. Okay, number 1. I'm not going to do it. You have to explain it to me. So, 7 times 5 plus 3. What would we do first?
First off, you would times 7 times 5.
Okay, so I'm going to make my funnel.
And you get 35.
Good.
And then you plus 3 and you get 38.
This is exactly how your work should have looked for me today. We do multiplication first. We do addition first. All right, I want 2 claps and a Ric Flair. Good job. 1, 2, 3.
Woo!
That was a weak Ric Flair. We'll have to do it again on the next one.
Guys.
Number 2. Parentheses 28 minus 20, parentheses, divided by 4. Gio, what's going to come first, big guy?
28 minus 20.
Okay. Parentheses are first. I get 8 divided by 4.
Oh yeah, that is the 2.
Good. 8 divided by 4 is what, Gio?
Huh?
What did it equal? Good. Alright, 2 claps and a Ric Flair for Gio. 1, 2, 3.
Woo!
Alright, number 3. This is the hardest one that we have so far. We have brackets per 6 plus parentheses 15 minus 10 parentheses brackets times 5. Grant, what do we do first, bud?
Okay, so 15 minus 10 is 5.
Good. So everyone pay attention. Make sure you get this. Brackets first. Inside the brackets, we have parentheses. So 15 minus 10 is 5. I have to rewrite it. I still keep my brackets because I have not finished what's inside there. My parentheses disappear, but not my brackets.
Then you do 6 plus 5 is 11.
Okay. Inside brackets, 6 plus 5 is 11.
11 times 5 is 55.
Did we do it right, or does anyone have a question? Always check. Don't just accept what we're doing. If you have something different, watch us and raise your hand. But I did this because sometimes he makes a mistake, and I do too. I failed at this a lot. Okay, we all good with that? All right, let's do 2 claps and Ric Flair this time again. 1, 2, 3. That was a little better. Oh, it did it on this one too. I don't know why it didn't copy all my notes over. Alright, so I gotta do notes on a blank page. Alright, let me get notes out here. Alright, number 2. Evaluate 30 divided by 7. Oops, I'm sorry. 30 divided by parentheses. 7 plus 2 to the third parentheses times 6. What's different in this one? There's exponents. That's all we're going to look at. So now, gentlemen, let's not just be dancing around playing, or you may go somewhere else. We're only going to add one extra step. Okay, so I'm going to show this one to you again. Evaluate. Like I said, I like to write out, Pam does. And my first step is parentheses or brackets, my grouping symbols. And I see I'm looking at 7 plus 2 to the third. Well, inside those parentheses, there are no other parentheses, but there is an exponent. So I have to simplify 2 to the third. We did that as a review. What does 2 to the third mean? What's that as repeated multiplication? Gio?
2 times 2 times 2.
So I'm going to show work on the side. 2 times 2 times 2. Well, that's 2 times 2 is 4. And then 4 times 2 is 8. This time, when I rewrite my problem, I'm going to have 30 divided by, I have to keep my parentheses because I did nothing with that 7. All order of operations is, in the funneling that I call, all it is simplifying it. We're making a big thing look smaller. Remember how I told you mathematicians, we can be lazy like that? Instead of saying 2 times 2 times 2, we say 2 to the third. Well, instead of having this long operation, we just want to get it down to one number. So I simplified. 2 to the third became 8. I am then going to work on my parentheses still. 7 plus 8 is 15. And I copy my problem down. Do I need my parentheses around the 15 anymore? No. When I get it down to a single number, I may get rid of parentheses. Big question. Raise your hand. I have 30 divided by 15 times 6. What is my next step? Elizabeth?
30 divided by 5.
Why do I want to do 30 divided by 15 before I do 15 times 6?
Because that's what comes first when going up.
Left to right. So I have no more parentheses, I have no more exponents, but left to right, I do multiplication division. There was division. So 30 divided by 15 is 2. I rewrite my problem, 2 times 6, which is 12. Alright, same thing. Turn, work with your partners. Let's do 4, 5, and 6. Alright, back together. So even if we're not quite done, it looks like most of you, I like how you guys are working together. You're doing awesome. We're almost done with this lesson. So, number 4. 6 plus 2 to the 4th minus 1. Who can explain this to me? Yes, what do I do first?
You do 2 to the 4th power.
Okay, 2 to the 4th power, which is 6. What?
16. Yeah.
Okay, 16. Good, because it's like 2 times 2 times 2 times 2. 2 times 2 is 4. 2 times 2 is 4. And 4 times 4, oh, I'm sorry, you can't see
How
that
about
word, is 16. Okay? 2 to the 4th meant 2 times 2 times 2 times 2, which you give us 16. All right, I rewrite my problem. All right, now what do I do?
Now you add.
I add. How come I do the addition instead of the subtraction?
And it's on the left.
Very good. Left to right. That gives me 22 minus 1. 21. Awesome. All right, let's give her. You guys remember the Hulk Hogan?
Yeah.
Good job, brother. So 2 claps and a Hulk Hogan. 1, 2, 3.
Good job, brother.
Kingsley's turning red. She's like, I'm not a brother. Alright. Let's do number 5. Who thinks they can explain number 5 to me? Miss Quick, I want you to explain number 5 to me. How can I do number 5? What's first?
First I did.
It's what?
First I did exponents and I got 9.
Good, so we do exponents. Let's make the filter. 3 squared, she said, was 9. So 4 times 9 plus 18 minus 9. What's next?
And then I did 4 times 9 and got 36.
4 times 9, 36. I rewrite my equation. And then?
And then I did 36 plus 18 and got 54.
54 minus 9.
And then I got 45.
54 minus 9 is 45. Oh, I'm happy I caught on you because in my head I did 54 minus 9 is 63. Ooh, I did the wrong problem. Alright, so it is 45. Great job. 2 claps and a Hulk Hogan. 1, 2, 3.
Good job, brother.
I love that one. Last one, number 6. Who thinks they want to take a stab at it? Alright, go ahead for it. Grant.
So first you would do 5 to the 2nd power, which is 25.
Good. So in parentheses, 5 squared. And so I do my exponent first. 5 squared, like you said, was 25. I rewrite this. I still need my parentheses because I did not simplify the whole parentheses yet.
Then you do 25 minus 7, which is 18.
Good. My parentheses now go away because I've simplified it down to one problem.
Then 18 divided by 3 is 6. And 16 plus 6 is 22.
Let's give him. Let's give him a Mary Poppins. So Mary Poppins goes bibbidi bobbidi boo. So we'll do a 2 cups and a bibbidi bobbidi boo. 1, 2, 3. Bibbidi bobbidi boo. I like that one. Is that Mary Poppins? Who's bibbidi bobbidi? Is that Snow? No. Cinderella? Cinderella. Fairy godmother. Ooh, we should say fairy godmother. Okay. Way to make fun of my claps. Alright, last one. Example 3. What we're going to do with this is we are actually not going to do all the triads because we did not put this on your homework. It's pretty complicated, but in case you see this on test or NWEA or anything, I want to explain it. You notice this one has a fraction in it, right? Alright, what does fractions mean to do? Here we go. What operation is a fraction? Fraction represents, does it represent addition, subtraction, multiplication, or division?
No, I know that. Division.
It represents division. I'm going to write on my board real quick. And I actually used this yesterday. I had to go to Costco and I was getting stuff. if I have 1/2, that also represents my numerator being divided by my denominator. 1/2 is 1 divided by 2. 1/2 equals 0.5. If I did 1 divided by 2, you get 1.5. We use fractions for a lot of things. Divisions, ratios, so parts of a whole. If I was taking a division problem and I said 10 divided by 5, 10 divided by 5 is obviously what? 2. But if I wrote 10 divided by 5 as a fraction, we would write 10 over 5. And as a fraction, 10 over 5 is 2. It still equals 2. If I have 10 small parts, and I could put 5 parts in one whole, I'd get 2 whole. Because of that, we are going to rewrite this problem. Now, the first thing we have to do is we look at the numerator. And there's something going on with our numerator. I have 8 minus 2, so we're going to rewrite this problem. I have to do that first, okay? So in my fraction, I have to do that first. So we will make what? What makes sure that I do that problem before anything else? We put parentheses. Good job, Elizabeth. I'm going to say parentheses 8 minus 2. Now, when I do a fraction, I have to divide my numerator by my denominator. So when I do 8 minus 2 first, then I'm going to say I'm going to divide it by 3. And then I still see I have a 9 plus. Now, to be totally honest with you, I don't have to do this because the last one's plus. But, in case it wasn't, because that numerator was going to my my denominator is going to my numerator, we would put brackets around it. Mainly, if you are writing a fraction into a numerical expression, which we just did, you would use brackets to put the numerator and denominator together. Parentheses in case anything's happened to our numerator, and anything if it's going on to our denominator. Okay? Okay, we are actually going to stop there. Oh no, I got to do the next example because there's one other reason. We're not going to solve that one. I fully believe you can. But I want to show the work on this next one for an important reason. Last one we're going to show our work on. 10 minus 8, parentheses 13 plus 7 divided by 4 to the second power. What do we do first? Graham? Parentheses. So, here's where we're going to get tricky. 13 plus 7 is 20. Do I need to write parentheses around it anymore since I got it down to one number? Good. Let's rewrite our problem. 10 minus 8. Now, because we got rid of our parentheses, because we can, I don't have anything there. So is this now 10 minus 820? So what do I do there? I like that. I saw that, Lily. That was cool. I like that. All right, Lily. I like how you did your symbol. What do? We multiply. Anytime you have a number sitting outside of parentheses, it means to multiply the two. You are essentially doing distributive property. So I'm going to get my red pen to point this out. Means multiply. I'm going to put over on my side notes, if I was to do 2 parentheses 3, I promise you, when you get to 8th grade, you're going to see this a lot. When I taught the algebra last year, we had that written out a lot of times. 2 parentheses 3. Or we do it with variables. We'd have like 2 parentheses 3x, y. And it means to multiply. A number outside parentheses means to multiply. Okay? Alright. I'm done. We're going to quit doing examples because I want you guys to have time to work. But I have to show you one example. The quicker we do this, the more work time you have. Where are these going to go?
In your binder.
Good. They should go in your Avid binder. What I need you to do, though, is let's get out a blank piece of paper. No, those are just notes. And that goes in your binder right in front of morning work. Notes should be put away. We'll give out a blank piece of paper. I'll have you get on big ideas in just a second after we model how your homework has to look. I told you, I'm always completely honest with you. Lesson 1, I was not as strict about you turning in your homework because I'll look at the people that did. But honestly, most of it, you didn't really need any work. Today, you must show me work. Alright, where did I put that? Alright, you guys ready for our example? I'm going to do an example problem. Yeah, that's okay. I'm going to do one example for you, and this will show you how to do your homework. You must show your work on all your homework. So, I'm going to put EX if you want to do this with me. 6 divided by 2, parentheses, 1 plus 2. This is the Facebook problem everyone is arguing about. Now, let's do PEMDAS together. And I'm going to show you how I'm showing my work on my paper. What should I do first? Ainsley, what should I do first? Okay, the way I show my work is because I like to space things out. I make my funnel take one line. And I do 1 plus 2 is 3. 6 divided by 2. And what did Lily say? What are we doing here now? We're multiplying. Now, due to order of operations, what should we do next? Kyo? Kiori? Kyo. I saw Gio, and I saw you, and I mixed you guys. We would divide left to right. 6. Once again, I'm making my funnel take one line. 6 divided by 2 is 3. And I'd have this left. Last thing I have is 3 times 3, which is?
That's easy.
That is the answer.
How are they doing it?
How are they getting annoyed with that?
They are arguing because people are doing the first step. 1 plus 2 is 3. But since the 2 is right outside the parentheses, they say you have to distribute that now and do 2 times 3 is 6. 6 divided by 6 is 1. So they are arguing that the answer should be 1. Lily just proved them all wrong. Everyone on Facebook that's arguing about 1, she's telling them they are a bunch of idiots. Because, order of operation, when we get parentheses done, we can leave it blank or we can get rid of them. even if I did not, even if we left the parentheses, and I did, I rewrote my problem as 6 divided by 2 times 3. Okay, PEMDAS, parentheses first. Is there any equations inside my parentheses? No. Are there any exponents? No. Multiply and divide left to right. 6 divided by 2 is 3. And then, what does the 3 outside the parentheses represent? Multiplication.
You should take a picture and post this. And say this
How
is
many
my
people
kids.
argue? So, this is what I expect from you guys today. There are 17 problems to your homework. The first 2 are review. Might be 4. I think it's 2 are review. But you need to show your work on every one of these. Okay? I think there might be the first 2 you probably don't have to show your work. And then there's a problem solving one you might not have to. Otherwise, show your order of operations. And what's the number one thing you must do after you answer a question online?
Check it.
Check it. If it's wrong, look back at your order of operations. You have almost 15 minutes. Log into Big Ideas. Your assignment is listed. I want to come around. I will help you any way you need. When is this due again?
Friday.
Friday at what
7 a.m.
time? 7 a.m.